Space is vast, mysterious, and terrifying. For millennia we've gazed up at the night sky, searching for answers among the stars. But the more we learn about the universe, the more we realize just how much remains unknown, shrouded in a darkness that stretches out to infinity. Today, we're diving into the scariest facts about the universe that will leave you in awe and fear. From the unimaginable emptiness of the Butte's void, to the universe's inevitable demise in a cold, dark whisper of heat death, we'll confront the cosmic horrors that lurk beyond our pale blue dot. Fasten your seatbelts, space travelers, because this journey isn't for the faint of heart. But for those brave enough to explore the cosmos's darkest corners, the reward is a newfound appreciation for the delicate beauty of our own existence. Imagine a place so empty, so devoid of light and life that it chills you to your core just thinking about it. Now magnify that emptiness to a scale that defies human comprehension, stretching for hundreds of millions of light years. This isn't science fiction. This is the Butte's Void, a cosmic desert so vast and barren that it makes up a staggering 0.27% of the observable universe. To put that into perspective, if our Milky Way galaxy were a grain of sand, the Butte's Void would be a yawning chasm larger than the entire Earth. Within this void lie just a handful of lonely galaxies, scattered like dust motes in a cathedral. These galaxies, separated by unimaginable distances, exist in an almost perfect vacuum, their light barely a flicker in the overwhelming darkness. The very existence of the Butte's Void challenges our understanding of the universe's formation. How could such a vast region be so devoid of matter, so absent of the cosmic structures that define our reality? Some theories suggest that the void might be a result of smaller voids merging together, like soap bubbles coalescing into a giant empty sphere. Others propose that it could be evidence of even more exotic phenomena, perhaps hinting at the existence of other universes pressing against our own. Whatever the explanation, the Butte's Void stands as a chilling reminder of the universe's vastness and our own insignificant place within it. It's a silent abyss that whispers of the unknown, a cosmic graveyard where even light itself seems to get lost. We often think of planets as being tethered to a star, orbiting in a celestial dance that provides light, warmth, and the possibility of life. But what if I told you that there are billions, perhaps even trillions of planets wandering the galaxy alone, cast adrift in the cold depths of space? These are the rogue planets, cosmic orphans ejected from their star systems by gravitational interactions or violent stellar events. They roam the interstellar void without a sun to call their own, shrouded in perpetual darkness and locked in a state of perpetual winter. Imagine a planet, perhaps once teeming with life, now reduced to a desolate wasteland. Its oceans are frozen solid, its atmosphere a thin, icy veil, its surface scarred by asteroid impacts that leave behind craters of eternal night. But even in this desolate landscape, there might be a glimmer of hope. Some scientists believe that rogue planets could harbor internal heat sources, geothermal vents spewing forth energy from deep within their cores. Could these internal furnaces provide enough warmth to sustain pockets of liquid water beneath the surface? And if so, could life, however alien, find a way to cling to existence in these hidden oases? The possibility is both intriguing and terrifying. It suggests that life might find a way to exist even in the most extreme and unforgiving environments, but it also paints a bleak picture of isolation and darkness. As we continue to explore the universe, we're bound to encounter more of these rogue planets, each one a chilling reminder of the vastness of space and the fragility of our own existence. They are nomads of the cosmos, forever adrift in the emptiness, their stories lost to the void. In the cosmic tapestry of the universe, there are few objects as fascinating and terrifying as black holes. These gravitational behemoths are formed from the remnants of collapsed stars, their cores crushed to an infinitely small point known as a singularity. Imagine a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. This is the event horizon, the point of no return, beyond which all paths lead to the singularity at the black hole's heart. As matter spirals inward towards the event horizon, it's stretched and torn apart by tidal forces, a process known as spaghettification. Time itself warps and distorts under the black hole's immense gravity, slowing down to a crawl for an outside observer. At the singularity, our current understanding of physics breaks down. Here, matter is compressed to an unimaginable density, and the laws of nature as we know them cease to apply. Black holes are the ultimate cosmic vacuum cleaners, devouring anything that ventures too close. Stars, planets, even entire galaxies can be consumed by these gravitational monsters, their light extinguished, their stories swallowed by the abyss. But black holes are not simply agents of destruction, they also play a crucial role in the evolution of galaxies, their immense gravity shaping the distribution of stars and gas. The study of black holes continues to push the boundaries of our understanding of the universe, revealing the intricate workings of gravity and the fundamental nature of space and time itself. They are reminders that the cosmos is a place of both breathtaking beauty and unimaginable power, where the laws of physics are pushed to their limits. Imagine the unimaginable, a blinding flash of light, brighter than a billion suns, erupting without warning from the depths of space. This is a gamma-ray burst, the most powerful explosion in the universe, capable of releasing more energy in a few seconds than our sun will emit in its entire lifetime. These cosmic death rays originate from the most cataclysmic events imaginable, such as the collapse of massive stars into black holes or the collision of neutron stars. They travel across the universe at the speed of light, carrying with them the potential for unimaginable destruction. If a gamma-ray burst were to occur within a few thousand light-years of Earth, the consequences would be catastrophic. Our planet would be bathed in intense radiation, stripping away our atmosphere and boiling away our oceans. Life, as we know it, would cease to exist. The sheer power of a gamma-ray burst is difficult to comprehend. It's a reminder that the universe is a violent and unpredictable place, where even the most distant events can have profound consequences for our own planet. Thankfully, gamma-ray bursts are relatively rare events, and the chances of one occurring close enough to harm Earth are slim, but they serve as a stark reminder of the immense power of the cosmos and the fragility of our own existence. Though we might like to imagine ourselves safe and secure on our little blue planet, we are, in reality, adrift in a cosmic sea of unimaginable energies, subject to forces beyond our control. The universe, as we know it, is a place of constant change, a never-ending cycle of birth, death, and renewal. Stars ignite, burn brightly for billions of years, and then fade away, their fuel spent. New stars are born from the ashes of their predecessors, carrying on the cosmic cycle. But what happens when the cycle finally comes to an end? What is the ultimate fate of the universe itself? The prevailing theory among cosmologists is a chilling concept known as heat death. It's a scenario where the universe continues to expand and cool until it reaches a state of maximum entropy, where no more work can be done and no more energy can be extracted. Imagine a universe where all the stars have burned out, their light extinguished, their energy dispersed into the vast emptiness. Black holes will have consumed all the remaining matter, eventually evaporating themselves into faint whispers of Hawking radiation. Temperatures will plummet to absolute zero, and the universe will become a cold, dark, and utterly lifeless void. Time itself will lose all meaning, as there will be no events, no changes, only an endless, static expanse of nothingness. The heat death of the universe is a profoundly unsettling concept. It suggests that all the beauty, all the complexity, all the life that has ever existed will eventually be erased, leaving behind only an empty, silent abyss. But even in the face of this cosmic inevitability, there is a strange kind of beauty. The universe, in its death throes, will return to a state of perfect simplicity, a blank slate upon which new possibilities might someday arise. Space is as beautiful as it is terrifying. These facts remind us of how small we are in the grand scheme of the cosmos. We are but a tiny speck of life in a vast and indifferent universe. But this doesn't mean we should despair. On the contrary, it should fill us with a sense of awe and wonder. The universe is full of mysteries, and we are privileged to be alive at a time when we are beginning to unravel them. So stay curious and keep looking up, for in the exploration of the cosmos, we may just find the answers to life's biggest questions.